All right. I believe with that, we should be on the internet. I'm going to go grab that link and put it in a couple of places, and then we can get started. Yes. Go. So the way this works is, and you've been on the show before, so you remember this, but I'll start with just me. I'll do a brief introduction, and then I'll do a brief introduction for you, bring you on, and then we'll talk for probably about an hour, and then at the very end I'll do sort of an outro. You can stay on the call if you want to. I describe it. I describe the show as it's as if two new friends sit down and geek out over some piece of technology, and that's just
Sure,
yeah.
that sounds good. Actually, the last time I was on the show, it was with Randall and Simon Phipps, and Randall
Mhm.
was at some conference with very poor internet connectivity, so I
Right.
ended up talking with Simon mostly about licensing.
Simon likes to talk about licensing. That's kind of his thing. Yeah, I have Randall and Simon on as co-hosts from time to time too. Everybody is exceptionally busy around the holidays right now. That's why I'm doing it solo for a few episodes. But it's always fun to be able to have the guys back, help out as
Sure.
co-hosts. All right, and I've got your topics. I think I have everything I need. We are a few minutes early, but I think we can go ahead and get started. So here we go. Hey folks, it is time for FLOSS Weekly. That's the show about free, Libre, and open source software. I'm your host, Jonathan Bennett, and today I'm flying solo, no co-host, because it's around the holidays and everybody has stuff going on. But that's all right. The show must continue, at least this week. I do reserve the right, if I don't get a guest, to take off right around Christmas. But it's on the calendar, so we may make a show there. Anyway, today we have a returning project, a returning guest even. We were talking before the show started a little bit about what happened last time. We'll get into that in just a second. But we've got KS Bhaskar of the YottaDB project, and I don't know a whole lot about this, and so we're going to spend a little bit of time talking about what makes YottaDB different, what its sort of niche is. My database experience basically boils down to MySQL / MariaDB and SQLite. That's about it. That's about all the SQL that I've done. So this will be broadening my horizons. Let's go ahead and bring the guest on, Mr. KS Bhaskar. I've been told to just refer to him as Bhaskar, and maybe there's a story behind that as well. But welcome back to the show, sir.
Hey, Jonathan, good to be here, and
It
thank
is
you for having me.
It's great to have you again.
Um,
So you were saying that the last time you were on, it was Randall and Simon, and Randall was at a conference.
Yeah, Randall was at a conference and had very poor Wi-Fi connectivity. It kept coming on and going off. So I spent most of the time talking with Simon about licensing
Mm-hmm.
rather than talking about technology. Which is kind of interesting. I mean, licensing, something that Simon is a specialist in.
That is definitely his thing. That is something that he really enjoys. He geeks out over that. It's his thing. So let's talk about the technology then. Let's start there. And we're talking about YottaDB. And as I said, my database experience is basically limited to, I don't know, what are probably the two most popular, at least open source databases, the MariaDB and the SQLite. What sets YottaDB apart from those two and everything else? What's the niche?
Sure. I mean, it's a good question because at this point there are probably hundreds of databases that are out there, and a large number of them are open source. So basically, the things that set YottaDB apart, one, it's a key value database. It's not a SQL database,
Oh, okay.
though we do have a SQL layer that goes on top of it. And if you get down to it, fundamentally, every database has got to store data one way or another, and key value is one of the most fundamental ways of storing data. So it actually gives you access to the data at a very low level. And other than that, I think the claim to fame of YottaDB is the fact that the code base is mature, it's extremely scalable, far more scalability than pretty much any other database I know of. Very strong support for ACID transactions and creating mission critical applications where you really have to have 5 nines availability, things like banking and healthcare and so on. So those are the things that it's good at. It's also language agnostic, and it has different models of how it works. There's no daemon. There's no the transactions use optimistic concurrency control and things like that. So it's a different kind of database that way.
What do you mean? There's no daemon. There's no application. It's an odd statement to my ears, at least, because it sounds like you just said that there's no actual application running.
Well, so if you think about, let's take a couple of SQL databases, Postgres versus, let's say, SQLite.
Okay.
So Postgres actually has a daemon, so the database is different from the application.
Right.
Now, in the case of SQLite, the application basically just directly connects to the database. So in the case of YottaDB, we actually have an API. So there are APIs in multiple languages, and your application code directly calls the API. The runtime system of the database actually resides within the address space of the processes that access the database.
Oh.
And the processes essentially cooperate with one another to manage the database. So this actually has a lot of benefits from the point of view of security and scalability and lack of single point of failure and so on.
They handle concurrency right in the applications?
The runtime system, it's part of what you link in the application. So let's say that take a C API. So when you compile your application, or when you create your application, you basically do a pound-sign include in the header file, and it provides a bunch of functions. Now, these functions are part of the YottaDB runtime system. So when the process runs, the functions actually will open the database file. Different processes will then cooperate to manage the database file. They cooperate through shared memory control structures. So the first process that opens a database file essentially sets up the shared memory control structures, and the last process tears them all down.
It's really interesting. So you, in a way, and I'm going to butcher this, but in a way, the first process that opens the database becomes the daemon.
No. Every process is essentially, they're all pairs.
Okay.
So there are control. So let's take we'll walk through what happens. So there are buffers in the shared memory control structures. So and again, the database. Let me take a step back. The database itself consists of database files.
Right.
And you can have something like 2 to the power of 32 different database files in a database.
Just a few, yeah.
Just a few. I don't have anyone that goes beyond a few tens, but we chose the name YottaDB because when I started the company, I did a back of the envelope calculation and said we could actually have a database that can store a yottabyte.
Nice.
So that's where the name comes from.
Right.
But so for an individual database file, for each database file, there's a shared memory segment. And the database file itself consists of blocks. So when a process wants to access a node in the database, it pulls, if the blocks are not resident in the shared memory, it pulls those blocks in, and there are copies in the shared memory of those blocks. Now the next process comes along. If it wants to access something in the database, if the blocks are already in shared memory, it pulls them in. If the blocks are not in shared memory, it goes out and pulls them in, making them available to other processes. And there is similar logic for when a process wants to make an update, or when there is a transaction, there is logic that handles that as well. So the processes basically all cooperate through these control structures in shared memory.
That's really intriguing. That's a neat and very different, at least to me, that is a very different way to go about it. So how does it work over the network?
Well, we do have a client server protocol, but so for those, there is a server which listens on a TCP socket, and the client on a different machine can connect to it. But that's not the typical use case. So we often get into very large systems, and these are systems that may have, thousands or tens of thousands of concurrent users and databases running into multiple terabytes. And in cases like that, typically the application server runs on the same machine as the database. There is no separate database server.
Okay.
There is one server, the application processes and the database all run on that machine. And that's essentially how we get the very high levels of scalability that that people use us for.
So what kind of machines does YottaDB run on? We're not talking about deploying this for a Raspberry Pi, are we? I mean, you probably could.
But actually, funnily enough, it will run on a Raspberry Pi as well. We scaled down. So on a Raspberry Pi 3 with your consumer grade micro SD card, you can still get thousands of database accesses per second. But at the high end, people will run applications on x86 Linux servers, and these are machines that may have, hundreds of gigabytes of RAM, and may have, very high-end I/O subsystems. And so we scale to everything from the low end to the high end. We also run on ARM servers, which like a Raspberry Pi.
Yeah. I had in mind there the idea of like IBM Z series, your big mainframes. It almost sounds like you could run there too.
Well, in the past, the upstream code base was actually ported to IBM Z series mainframes. But an IBM mainframe doesn't really add anything to a database like YottaDB, because we have functionality for business continuity. From a performance point of view, those are not necessarily the highest performing machines. And certainly if you want performance per dollar, those are definitely not the best machines to choose from. So essentially choosing a good performant Linux server running x86 or an ARM 64-bit architecture, those are what will give you the best performance for your money.
Yeah, that makes sense. So what's sort of the origin story? At what point did you say to yourself, I assume, did you start the project? Let's start there.
Well, I started the company. I didn't start the project. So
okay.
So the code base actually originated in the 1980s.
Wow.
And was a company called Greystone Technology Corporation based in a Boston suburb. And they started a project called GTM. And GTM was deployed in high-end medical and banking applications. So I joined Greystone as the vice president of engineering in 1995. And you've seen the pictures of a small fish getting eaten by a bigger fish, getting eaten by an even bigger fish.
Oh, yes.
So that company got bought by a biggest customer, moved from Boston to Philadelphia. That company in turn got bought by a Fortune 500 company that primarily wanted to use the technology. And along the way, so the code base actually went into production in 1986. And in fact, at the Elvis Presley Memorial Trauma Center in Memphis. So you can't get better name recognition than Elvis.
Yeah.
But anyway, so what happened was that the parent company was, the Fortune 500 company was primarily interested in using the database for their internal products. And so back around 2000, 2001, we open sourced the code base. And in 2017, I had actually managed that code base from 1995 to 2017. And I left with a couple of the developers that had been with me for decades. And we started YottaDB to essentially take the code base to new applications and markets and so on.
Yeah, that is quite the history. So YottaDB predates open source and the GPL by quite a bit.
Quite a bit.
That it's impressive that the code was clean enough that it could be open sourced after that much time. We hear about some projects. Winamp. Winamp is the one that really comes to mind. They decided they were going to open source Winamp, and then people started looking in there at the code that they released and went, "This is not going to work."
Well, I will say that over the years, the code quality has improved. But that said, because of the fact that right from the beginning, the the use cases were these mission critical applications in healthcare and banking and finance. The code had to be clean. And in fact, our development process also ties into making sure that the code is absolutely rock solid.
And so what was sort of the decision? What did the decision look like to actually open source it? At some point there was this business that had been purchased by a Fortune 500. Was that about the time that the code was released?
It was when the biggest customer bought us and moved us down to Philadelphia from Boston. And basically, they too were primarily interested in the technology because they had a high-end banking application. And again, they wanted to use the technology. They were not really interested in the database business. And then it became obvious to me that over time, the bar for quality was not going to go down. It was going to keep going up. And with software, especially if we, using software is one of the things that makes it robust. If you just write software and, put it in, lock it up in a room, you're not going to find bugs because it's not being used, but it's not really going to be robust software. So if you want robust software that's used, you need to have a lot of people using it. So it became obvious to me that over time, we were going to invest an ever-increasing part of our resources in the quality aspect of the software. So I said, what we ought to do is take the software out and get a large number of users. So let's go ahead and release, since we're not interested in the business of the database business, let's go release this. And as I went out and talked to people, it became obvious that it wasn't going to be enough to just release the binaries as free software. We really, free as in free beer, but we really needed to release the code base and make it open source, as in the freedom type of aspect of open source. Right. And that discussion took place in about 2000 and 2001. And then what we had to do was essentially, put in copyright notices and all the other stuff to actually prepare the code base for release as open source. And we did that in May of 2021.
Not to rehash the entire conversation with Simon, but what license did you guys go with?
Well, at that time we went with GPL v2, which was the latest that was available. Then we went with GPL v3, and today the code base is AGPL v3.
Oh, Affera GPL.
Our philosophy has always been to use the license with the strongest copy left that we could, because we certainly have. Wait a second, I forgot to turn off my phone.
It happens.
So, we have some, potential elephants in the cage with us that would be very happy to use our software. And so we decided that we needed a strong copyleft license. So the database itself is AGPL v3. The language wrappers that we have, for example, the Go language wrapper, that's licensed under LGPL v2 because that's the appropriate license for the language wrapper.
And then do you do like do you do different licenses if someone wants to, let's say one of the elephants in the room said, hey, we would like to offer this as a service. We're going to pay you a lot of money. Do you have the option to do a sub-license where it's not GPL v3?
So they would have to work out a deal both with us and with the Fortune 500 company that has the upstream software, because and again, I managed that for so many years, and I was the one that made the decision to release under GPL v2, v3, and then GPL v3. But now they actually own the copyright. So if someone wanted to use a different license, they would have to go talk to both them and us. And then we've had a couple of contributions from the community. So but let's take a step back. I don't know why anyone would want to use a license other than AGPL v3, just because the way the software works, because of the fact that the database engine is linked in only once a process starts executing. You can have a completely proprietary application running with YottaDB.
Okay. I understand. They don't link together at compile time.
They don't link together at compile time. That's why the the language wrappers, which are some of which do link at compile time, are released under LGPL, but the database itself is not linked in until the process actually starts executing and opens a database file.
Interesting. Oh, that's clever. Huh. So you have then customers that use this with their, I guess in some cases, proprietary programs, because of the,
very often, yeah, we have customers using it with the proprietary applications, and we have customers using it with open source applications.
Yeah, interesting. So one of the questions I was going to ask then is, how in the world do you build a company? And I suppose it's still a good question. How in the world do you build a company and actually, pay your developers and pay rent with open source software?
I mean, same as you do any other business, which is with difficulty.
Yes.
So, it's one of those things where if someone is running, so one of our customers, for example, is a nation-scale electronic health record system. Mm-hmm. And if you're running an application on which your enterprise depends, you can either choose to hire developers to maintain the database, or you can enter into a support contract with YottaDB, and then we'll provide that support. And any support requests that come in go straight to the developers.
Mm-hmm. How big is that team? How many? If I call YottaDB, how many different people are there that might answer my tech support call?
Well, there are about 8 of us, and the thing is, we have some employees and some, some contractors that are, located around the world. So I can say that the sun never sets on YottaDB development.
Was that 8 or 80? I didn't quite catch it.
8, no, just 8.
8 of you. Okay.
8 of us. But again, we also benefit from the code releases of the upstream code base. And typically, when you have a support request, it's handled by 3 of us. And mm-hmm. These are 3 of us that have the most in-depth knowledge of the application and the database.
Mm-hmm. Yeah. I have found that having a business where you have people around the world, the time zone thing, it makes certain things particularly complicated. Particularly trying to schedule an all hands meeting can be very challenging. But that idea that someone is always awake to answer the phones, that's pretty useful.
Well, actually, it doesn't quite work that way. So typically, I mean, I have one of the support lines right now. I'm on secondary support. Mm-hmm. It comes directly to my cell phone, because the way that what we're really selling with a support contract is we're selling peace of mind. Mm-hmm. We're not, if we were to sell support by the incident or by the hour, one is that, in some sense, we're not making money until something goes wrong.
Right.
And that means that, if something goes wrong, the end user is not happy, because especially if it goes wrong at 2:00 in the morning. Mm-hmm. The frontline support is not happy. They're getting disturbed. And I'm not happy because I'm getting woken up at 2:00 in the morning by a support call.
Yes.
So the way that you make money in the support business is essentially, think of it like insurance. We're selling mm-hmm. peace of mind. So we have an incentive to make the software as absolutely robust as we can make it, so that it doesn't go down at 2:00 in the morning, and you don't need to call us at 2:00 in the morning. But we're there at 2:00 in the morning in case something untoward happens.
Right.
Let's say you have an earthquake under your data center, or those kinds of things. So
right.
We're here. And so the primary support right now happens to be with our chief architect, and I have the secondary support.
Mm-hmm. I like that you've thought through that you want the incentives to line up correctly. And so you might even, I don't know if you sell it this way, but you probably think of it this way, that when someone is paying for a support contract, they're also paying for more robust code, because that is the part that makes everybody happy in that.
Yep.
Yeah, that's really interesting. I like that a lot.
Yeah, unfortunately, the flip side of that is I've actually had, the CIO of an organization tell me, why should I pay you? Because the software hasn't broken in all the years I've used it.
Yes. Yeah, I'm sure. I'm sure you've gotten that. It's unfortunate because that's a really short-sighted uh, place to stand. But they'll eventually need help. Maybe a special rate just for them, right? So when you talk about interacting with the community, what does that look like? Do you get patches from the community? Is it a project such that people are adding features, bug fixes? What does that community involvement look like?
So typically for the core database, we've only had small enhancements from the community. So for example, we had someone send us a faster sorting algorithm for the garbage collector, and it sped up the garbage collector. Other things that we've had from the community, in fact, the most common, I would say, are language wrappers. So the database itself has got a native C API, and C is the lingua franca of computing. So the most recent one, for example, is a member of our community from Germany added a language wrapper for a language called NIM, which I had not heard of until he, emailed me one day and said, I just created this wrapper.
Right.
We have someone in England that created a wrapper for PHP. And of course, we have our own wrappers that, like the Go wrapper or the Python wrapper, which is what we've created. But those are things that have come from the community.
Yeah. Is it kind of a done project, like the coding? As you sort of look ahead, are there any like big features that you want to add, or is it kind of hit the point to where it's feature complete?
Well, it's feature complete in the sense that people use it for large mission critical applications. But being in the software business is kind of like being in the newspaper business. There's always something more for tomorrow.
Yes.
And so, as a for example, one of the things, especially with large computer systems today, they have NUMA architectures rather than uniform memory architectures. So with the NUMA architecture, having shared memory across multiple sockets actually slows down the shared memory. So one of the things we're looking at is basically trying to see how we can provide scalability by having CPUs along with, on NUMA systems. Right now, when people want to scale up, we tell them get uniform memory architecture. So there's always something more to do.
Yeah, sort of extending that thought forwards even bigger. I wonder, do you see a future where you support something like CXL, the Compute Express Link, and that lets you do crazy things like having pools of memory that's shared between servers?
Well, no, and part of that, I mean, we've discussed distributed shared memory in other contexts, but the reason we don't is performance is extremely critically tied to shared memory performance.
Right.
Especially when you're doing like transaction commits. And anytime you distribute memory, you're going to have latency associated with it. And in the context that we were talking about things like infinite band shared memory. And even there, we concluded that it was not going to give us the performance that our high-end systems needed.
So the solution is just throw bigger servers at the problem.
throw a bigger server at the problem.
I mean, sometimes that is the right answer. That really is.
Sure. I mean, if you're running a large system, take for example the nation-scale electronic health record system or a large bank that's running on one system. That is a patient-centric system. So essentially, whoever sees the patient, wherever they see the patient, the fact that the database is a patient-centric system means that they have access to that patient record, and any change they make goes directly into the patient record. So even if you have, providers that may be hundreds of miles apart, they still see the same data in real time.
Yeah. Yeah, that makes sense. As you think about sort of the problem space that YottaDB solves, is there anything that really sticks out as, if you have this problem, go find a different database solution. We're not the ones for you.
Well, right now it's SQL. So if you have a problem for which a SQL solution is the best fit, go use a SQL database. Now, what we're working on, this is one of the areas where we're doing more, is we're actually we have a SQL engine that sits on top of YottaDB. But it's not as mature. It's basically SQL 92 at this point. And I'm sure that it's never going to catch up with Postgres or MariaDB or the other big databases, just because they have years of head start over us. But that's one application where I would say find another database.
Yeah, probably also if someone needs something that's really, really distributed, it's not really the one to use.
If someone needs something that's really distributed, which typically means that you're not really looking at strong transactions, right? You don't necessarily care about getting the right answer. You care about getting an answer. So take a search engine, for example. If you're doing a search engine, there is not necessarily a uniquely correct answer. So that if you're running a search and I'm running a search at the same time, if you get slightly different answers, that's okay. But that's not acceptable for a banking application or a medical application.
Right. Those answers need to match. Yes. That's funny. Okay, so obviously the craze right now, the bubble that we are living in, is AI. And so are you guys on the AI bandwagon? Are you rolling out AI features for YottaDB?
Well, not directly. YottaDB is usable for AI applications,
right?
Because of the fact that an AI application is essentially a vector database is basically a key value database. Now, what we've talked about doing is picking an existing database that's used for AI. I mean, take something like Chroma. I'm just picking that name out of because there are many of them out there. And we can create an API on top of YottaDB that matches that of the other application. So we've talked about doing that. Again, it hasn't come to the top just because we have our work pipeline is full. But certainly for AI, just because of the extreme level of scalability of the database and the fact that we can create APIs for pretty much anything you want, because the key value store is kind of the low level of storage. We could use, you could use YottaDB for AI.
Yeah, I imagine it would be trivial enough to build. I forget the term. A plugin to allow some agentic API. So somebody's running an MCP. There's a way to hook a YottaDB instance into it as a service it can talk to.
Yeah, I'm sure. It's not something, as I said, that I've spent a lot of time looking at.
All right. What about transactions? So, we already covered sort of this idea that whenever a program first opens the database, it loads the server code and begins running it. We talked a little bit about concurrency, but what's the juice that makes the transactions themselves so fast? How do they work so well?
So it's something called optimistic concurrency control. And this was something that there's a seminal paper from, I want to say, the 1980s by Kung and Robinson that talks about it. But the majority of databases actually use what I'd call pessimistic concurrency control.
Right.
Or locking of some kind. So what we do, and this is sort of getting into the weeds, so stop me if I'm going into too much detail, but every database block has got a transaction number which represents the transaction number at which the block was last updated. And every time you update the database, the transaction number is incremented.
Okay.
And it's a 64-bit counter, so it's not going to get, roll over in my lifetime.
Right.
So, and when a process does, so a transaction, you can think of it as a transaction start and a transaction commit.
Mm-hmm.
A space and time or a space and code. When a process does a transaction start, every time it accesses the database, it keeps track of which block it has read, block number, and the transaction number of that block.
Mm-hmm.
And even if it needs to update a block, it has to read the block first. So this keeps, is like a complete set. Any updates that the process makes, it keeps in process private memory. It doesn't commit it to the database. So when it comes to the transaction commit, it basically looks at all of the blocks that it has read. And then it says, has any of them changed since I read them? If none of them has changed, it can commit the transaction. If any of them has changed, it basically rolls back the state of the database to the start of the transaction. And then it repeats this. And it does it 3 times, and the 4th time, so basically you can have random collisions, but in practice, let's say I'm at an ATM and my wife is at an ATM. We're not going to be both doing exactly the transactions against the same account at exactly the same time. So most of the time, the transactions will just go through without colliding. Now, if there is a collision and one of the blocks has changed, then it basically rolls back the state to the start of the transaction and repeats the process. And it does it 3 times, and then the 4th time it basically says, okay, there is some pathological application issue which is causing the collision. So at that point, it does use pessimistic control and lock everyone else out of the transaction and go through the transaction on its own.
Oh, so it's a hybrid. It can do both. It's almost
in practice, those are pathological cases. So when people have performance issues, we will tell them to look at transaction restarts.
Yeah.
And we'll see usually, some number of first restarts, some number of second restarts. But if we see third restarts, then we know that there's something in the application which is causing the restart. And then we have tools to help them identify that.
Somebody did something dumb. Somebody is writing to the database every time the page gets loaded or something like that.
Well, as a common example of a programming error like this is someone says, I'm going to increment a transaction counter, or I'm going to write a log every time there is an update to the database. And of course, these logs are going to collide. Every one of them is going to collide in a high throughput application.
Yes. Unintentional recursive programming.
Exactly.
It's fascinating, though. That's almost it's sort of a speculative execution. It's very similar to what happens in CPUs because they do the process ahead of time and they look back to check that what they did, it works, and then they can just apply it and jump ahead. It's a very similar concept.
It's exactly the same concept.
Do you run into any of the security problems that we have had in speculative execution? Could someone run a Spectre attack on YottaDB?
Well, the difference is speculative execution in hardware does lend itself to side channel attacks. Now, when you're talking about software, anyone that has root access in the computer system can look at the memory and, so at that point, we do allow someone to use like SE Linux or AppArmor or things, or, other role-based controls. But essentially, anyone that has the right privileges on the computer system has access to, the shared memory segment. So it's a different type of problem. The way you have to control it is by controlling who gets access rather than by looking at side channels.
Mm-hmm. I asked that question sort of tongue in cheek. I didn't really expect that there was for that to really be a problem. You would have to have like a security boundary inside of YottaDB, and so I didn't really expect that to be a thing. But I thought it might be interesting.
Well, security boundary is in fact the computer system. If you're running on a back-end server, you're typically not exposing yourself to the internet where some random person can just mount a drive-by attack.
Right. Does YottaDB have like security boundaries internally? Can we assign for some of the keys that we manage? Can we assign different user roles and permissions?
You could do that. Now, one of our philosophies has always been that complexity is the enemy of security.
Mm-hmm.
So the way that the database works, a process is able to open a database file if it has the right to open that database file, and it can open it read-only or open it read-write. And that's based on the user group world model, which everyone knows how to deal with.
Mm-hmm.
And similarly with shared memory. So essentially, the security model of YottaDB is just a few pages in an appendix of one of our manuals, because what we say is that we rely on the operating system and implement security through the operating system.
Mm-hmm.
And by keeping it simple that way, we actually believe that it actually improves security. Now, that isn't to say that the operating system shouldn't have good security.
Right.
But the fact is that people who are developing Linux, people who are developing file systems, I mean, they're putting in far more man hours into developing security than YottaDB could ever hope to devote.
Mm-hmm.
So by relying on that, we believe that we actually try to keep things secure. We keep it secure, and we try to keep our security model as simple as possible.
Yeah. No, that's clever. That's really clever. We talked a little bit about the architectures that we run on. Is YottaDB primarily a Linux application? It sounds like it is.
Well, the code base is primarily a POSIX code base.
Okay.
So the two architectures that it ran on historically, one was the VMS architecture from a company called Digital Equipment Corporation that few people probably still remember. But it ran on that, and then there was a POSIX implementation that ran on Unix systems. And at this point, we do take advantage of some Linux features in YottaDB, but the API that we use is primarily the POSIX API.
So I assume if somebody wants to run it on like a NetBSD, FreeBSD, that's an option. Some of those other Unix compatible things.
Well, the upstream code base, today runs on AIX. That's not, they haven't released that as open source. That's still proprietary. Mm-hmm. And in the past, it ran on Solaris and HPUX and actually ran on IBM mainframes as well. Mm-hmm. So now, we've had people attempt to port it to, directly to run on Mac OS. And the key thing there is that, the way that the embedded language works in YottaDB is it's actually kind of interesting if you want to get into it, but it deals directly with things like stack frames. And those, of course, differ from OS to OS. So there's a process of porting to, Mac OS or another operating system that requires some porting effort. And again, if you're porting to different CPU architecture, because there is a small compiler that runs inside YottaDB for the embedded language, that would also have to be ported.
Mm-hmm. There's just enough wizardry where you can't just compile it on something new.
You can't, yeah, exactly.
Yeah. I remember someone saying that the modern Windows OSs were like 99% Unix compatible, and one of the only problems was that fork doesn't work the same way. Has anyone seriously thought about trying to get YottaDB to run on Windows?
Not that I know of. I mean, it does run under WSL, and in the past, I think it has run on Wine. Mm-hmm. But no, not seriously. I think that people have made serious attempts to get it to run on Mac OS, but not Windows that I know of.
Yeah, that's not surprising. Not a surprising answer. What about compilers? A lot of programs will just work. Say if you take it from GCC over to Clang, a lot of things will just work. But it sounds like you guys do just enough magic under the hood that trying to compile with Clang might be a real challenge.
Actually, we support Clang and GCC. So
Oh, okay.
in fact, on x86, I mean, we in part of our automated testing, we use both GCC and Clang.
Okay.
We have both of them in house. Our code base is compatible with both.
Oh, that's good.
Now, in fact, in the forthcoming release for the ARM architecture, we're probably going to release the production binaries on Clang rather than GCC
Oh,
because
interesting.
it turns out that on like Ubuntu 24.04 on ARM, there is a bug in GCC which causes some problems for us. So we're going to release with Clang.
Huh. Okay.
On x86, we'll release with GCC because that's what we've done for years.
Yeah.
Now, our compiler, so there are actually two. I mean, there's a C API for the database.
Mm-hmm.
We also have an embedded language called M, which anyone who's a history buff will recognize as, it used to be called mumps in the old days. But we actually have an implementation of M, which is embedded in YottaDB. And that code, when it's compiled, is actually compiled into something called indirect threaded code. And we do some nice things with the compiler and runtime system. So that's the compiler that has to be ported over when porting to a new CPU architecture.
Interesting. MUMPS stands for the Massachusetts General Hospital Utility Multi-Programming System.
Yes.
You guys originally started in Boston, Massachusetts, right? It sounds like MUMPS and Yotto has been sort of at the hip for a long time.
Since the beginning. So essentially, when the upstream code base was implemented in the 1980s, it was an implementation of MUMPS.
Aha.
And the key thing about MUMPS is that it was an integrated language at a database, and much of the power came from the fact that the language and the database were tightly coupled.
Mm-hmm.
In fact, that was actually, to the best of my knowledge, the second database that ever existed. The first one being something that was written for the Saturn V program by IBM and Rockwell called IMS. So this is run on a mini computer, and it was not a very powerful machine, and it got its power from the fact that the language and database were tightly coupled. So that's the origin story.
Mm-hmm.
And that in fact is the upstream code base has the two tightly coupled. Now, what we did when we started YottaDB was we said that the M language, as it's called these days, is not really that popular anymore. Mm-hmm. Applications that are written in the 1980s still continue to run unchanged. That code runs, but to create new applications, people need more modern languages. So what we did is we created a C API, and that C API has the same type binding to the database that the M language has. And so if you program in C, or if you program in a language that accesses the C API like Go or Nim or Python, mm-hmm. you basically have that same tight coupling between language and database that MUMPS offered back in the 1980s.
Yeah. Oh, that's really interesting. So it's almost we talk about SQL databases and SQL-like databases. It's this thing is almost an M database. It's almost a MUMPS-like database. It's kind of the where it falls.
Well, it is an M database, and then more. So we took the M database, and then we made it not tied to the M language. Mm-hmm. Traditional implementations of M, the language and database have been closely coupled. We basically said the database has value in languages other than M. So M is just one more language that we support.
Yeah, that's very cool. I like that. I like that a lot. I have a note here that says that apparently there's interesting things in how the heap is managed.
Sure. So
in fact, what is the heap in this context? Let's start with it. Not everybody, gets their hands dirty with programming. So tell us first, very briefly, what the heap is, and then why it's fascinating here.
So the heap is basically dynamic storage. So when you allocate space for a string, or you allocate space for some quantity, it requires, let's say we're processing names of people. Mm-hmm. Your name and my name have different lengths. And so to allocate memory for that, typically it's allocated in something called the heap.
Mm-hmm.
And when you use space in the heap, if you're processing a number of names one after another, well, once someone is done processing the Jonathan record and they process the Bhaskar record,
Mm-hmm.
and then they process the James record and the David record and the Thomas record, at some point they're going to need to reclaim memory.
Right.
And this process is, and so this dynamic allocation comes out of an area of memory called the heap. And when you use a heap, you periodically have to go through and do memory management, which is garbage collection.
Mm.
Not a great name, but that's what it's been called since the 1960s.
Right.
And so, I guess is that enough of an explanation for our listeners?
I think so.
Okay. And so the way that we do garbage collection is essentially there are, it's a mark and sweep algorithm, as it's called, where essentially the process goes through marking all of the memory which can be reached, and then whatever memory can be reached, it compacts that, and then whatever memory is left is now available for reuse.
Mm-hmm.
So that's the basic mark and sweep garbage collector. Now, what we have coming up is we've actually, so there are two things. One is there's a sorting process involved. So if you have an application that has 1,000 items on the heap and another application that has 100,000 items on the heap, the sorting of the things that are accessible takes much longer on the process that has 100,000 items than the process that has 1,000 items.
Right.
The best sorting algorithms in the world can only do what is called an n log n sort, which
Mm-hmm.
means that if you have 10 times the memory, it's going to take maybe 30 times as long to sort it.
Yeah.
So we basically have a technique where we skip the sort and allow you to dynamically choose between sorting and not sorting. If you sort, then it's a bit more memory efficient. If you skip the sorting, now you have a little bit more of a CPU efficient algorithm. Though eventually, you will have to, do the memory compaction. But by skipping it on most of the garbage collections, we have the ability to either go for CPU efficiency, CPU performance, or to go for memory efficiency.
Yeah, interesting. And so you've essentially written this garbage collection code because you were in C, right? And so you've written this garbage collection code yourselves. It's not like, in something like Golang or Java where the compiler and the runtime do all that for you and you don't have to worry about it. No, you guys are you have to write this code.
Well, we're just like the guys who wrote the garbage collector for Golang or whatever else, we're hardcore C programmers. Someone has to write the code.
Somebody has to write the code. I like that. I like that a lot. I do some work on embedded platforms, and one of the fun things there is that in some of those platforms there is no garbage collection, and so if you allocate memory and then later deallocate it, but you've allocated something else, so if your memory allocation becomes fragmented, in some of those platforms, a fragment is a memory leak. And so you just got to be real careful about something that's fun. It's so nice working on full-blown computers rather than embedded hardware when we get to.
Look, one of my interview questions, depending on the interviewee, is often about memory management and different strategies for managing memory.
Mm-hmm. Yeah. So what is Octo?
So Octo is basically a SQL layer that sits on top of YottaDB.
Oh, okay.
So it basically, by the way, Yotta is the old Greek word for 8. So Octo is the modern Greek word for 8.
I see what you did there.
and Octo also happens to be the first name of Professor Octo Barnett, in whose lab the M language was first developed back in the 1980s. So it is a nice, play on names.
Yes.
But it's a SQL layer that runs on YottaDB. So we take a SQL statement, and from the DDL, we actually create internal structures that map the SQL tables to the low-level key value structures.
Mm-hmm.
And then when a SQL query comes in, we will compile that SQL query and run it, accessing the low-level key value structures. So in some sense, it's not that different from any other SQL database, which has to have some way of actually storing the data under the covers.
Mm-hmm. So this just occurred to me. One of the challenges, again, my mind goes back to security. It's one of the things I think about a lot. One of the challenges with SQL databases is SQL injection attacks. Does YottaDB have some flavor? Is there an M injection attack? And if not, does Octo open you up to that potentially?
So let's separate Octo from YottaDB. Octo,
sure.
But in YottaDB, because of the fact that the programmer is actually writing code to access the database. Mm-hmm. If you can write code that accesses the database, you can do anything with the database. So the concept of a SQL injection attack doesn't really exist.
Right.
Now, Octo potentially could do that. We have some mechanisms in place for saying that a SQL query has to be a read-only query, or if it's read-write, then you have to have it appropriately configured for read-write access when you get into Octo. So, right. But it's certainly not mature in the same way that other SQL databases are. And the primary use case for Octo today is we have people who are using YottaDB as their main production system. Mm-hmm. But then they want to have the ability to run queries against it using standard SQL tools, whatever those tools are. And so what we did with Octo is in this use case, we have real-time replication from the production system to another YottaDB database. And on that YottaDB system, we're running Octo. And we support the Postgres wire protocol. Okay. And so we essentially support clients that can then use the Postgres wire protocol to access their Octo replica. So analytics and reporting are the primary use case today. Our long-term vision is having a database where you have concurrent access to the data, both looking at it as a SQL table and looking at it as a key value table, as well as other ways of looking at it. But mm-hmm. There are things that we need to do before that can happen.
Yeah, that's a complicated ask. I can see why someone would want to do that, but that is not a trivial thing to accomplish.
Well, we don't have a whole lot more to do to do that. It turns out that within the database, YottaDB actually has functionality called triggers. Mm-hmm. So let's say if you're maintaining cross-references, you can actually set up a trigger so that every time you update a key value node, the cross-reference gets updated. And every time you delete a key value node, the cross-reference gets deleted. So what you now need is to have something where if you have a SQL database and you have access to the key value pairs, and the SQL database now has to have some kind of consistency across tables. Well, the relational part, if someone makes a key value update, you need to make sure that the SQL consistency is maintained. Mm-hmm. And so we have the low-level functionality for doing that, but we need to add some higher levels of functionality before we can actually go out and say you can use this database whichever way you want.
Yeah, makes sense. So the last question, obviously I get some hints here on a sheet of things to ask about, although a lot of these I actually asked without looking at the sheet. It's just the direction our conversation took. But the last hint that I have here is asking about places where YottaDB is not used but probably should be. Are there some use cases out there that you're like, man, I wish they would just use our stuff. It would make life so much easier for these guys.
Well, you mentioned one a little while ago, embedded systems. Mm. So if you look at a typical IoT stack, and I'm not necessarily talking about consumer IoT, but let's say industrial IoT, you have an edge and you have a center, and basically you have a large number of devices, let me use that word, on the edge.
Yeah.
feeding into a central application that's running in the cloud. And YottaDB scales up to the application in the cloud, and it also scales down to the edge. And I actually spent a fair amount of time trying to generate interest for YottaDB in these cloud-based applications.
Mm-hmm.
And came up with some sample use cases and blogged about them. But unfortunately, no one bit. So at some point we just said, okay, it's a great idea, but you've got to find someone just at the time that they're thinking of starting an application, or when they have a problem that their existing solution doesn't solve and they need to have a new solution.
Mm-hmm. Yeah, I imagine YottaDB can't actually scale down all the way to like ESP32 style embedded. It's got to have that Unix system to really be able to run, right?
Yeah, the smallest system that we traditionally ran on was like a Raspberry Pi Zero, which for some IoT applications is too small. I mean, it's too big.
Right.
But on the other hand, that's why I said industrial Internet of Things, because as a for example, let's say you have a 100-year-old pump, and one of the things you want to do in a pump is, and again, I'm getting into weeds, so stop me if I'm getting into too many weeds, but if the pump rotates at a certain speed, as it spins faster, you have increased efficiency of pumping. Mm-hmm. Until at some point you start to get turbulent flow around the blades. Mm-hmm. And at that point, the pump efficiency drops. And if you keep increasing the speed of the pump, eventually what happens is you get these small bubbles on the blades called cavitation, and they actually erode the blades of the pump.
Right.
So let's say you have an industrial pump. What you can do is you can put strain sensors on the pump, connect those strain sensors to a Raspberry Pi Zero. Mm-hmm. And as the pump works, you're now doing a real-time Fourier transform on the strain sensors. Mm-hmm. And you can actually see, so when you're doing the Fourier transform, you're going to get peaks at the multiples of the frequency.
Right.
Now, what you're going to see when you start to get turbulent flow is that the noise floor in the frequency domain starts to go up between these peaks. And then as you start to get cavitation, it really goes up quite a bit. Mm-hmm. So this is something that you can do in real time. You can take a 100-year-old pump that was not designed to be an edge device in an IoT system, but you can now instrument that, and now you can run that pump at optimal pumping efficiency just by monitoring the strain gauge with a Raspberry Pi Zero. And now if you have a pumping station that has a whole bunch of these pumps, you can put all of that into a central application, which is now turning on as many pumps as it needs in order to optimize pumping efficiency and minimize energy usage.
Yeah, interesting. It's fascinating to me when we talk about embedded. That term means different things to different people. Like I've got a couple of devices here that have 16K of memory, some 20K, I think literally 20K of memory, one of the devices that I tried to work with. And that was too little for me, but still, we talk about embedded a Raspberry Pi. It's two totally different worlds.
Sure. And the things you're talking about are like the computers that I started programming way back. I've been programming software for now over 55 years. Mm-hmm. And the first computer I ever used, the memory was 40,000 decimal digits.
Yep. That sounds about right. That's fun. All right. We're getting down to the bottom of the hour. Is there anything I didn't ask you about that I should have? I feel like we covered a lot of YottaDB.
Oh, look, you can have me talking about YottaDB for hours on end. So, and you didn't ask me about the indirect threaded code and all that, but that's just an excuse to come back for another future FLOSS Weekly.
There we go.
When you invite me back.
Yep, absolutely. That'll be fun. All right. So I am required to ask you a couple of final questions. I get angry emails if I forget to. And so what is your favorite text editor that you spend all day in and scripting language?
Oh, Emacs. No question. I've been using Emacs since even before GNU Emacs came out. And I'm probably too old to change.
Understood.
For my scripting language, actually, so, I've done a lot of shell scripting, but then the other thing is actually use M as a scripting language. So one of the features that we've added to YottaDB is the fact that you can say, pound bang, and then put a YottaDB thing, and then follow it up with M code.
That's awesome. I like that so much. That's so cool.
Well,
That's
you have
very
to
cool.
you have to have fun when you're doing code.
Yes, absolutely. That's very cool. I like that a lot. All right. Thank you, sir, for being here. It's been a delight to get to hear about the project and your history with it. I appreciate it so much.
Thank you. It's been fun.
Yes. All right. So that was KS Bhaskar about YottaDB, a very fun, very storied project. And we will have to have him on here after a while again to talk about what's changed. We do have a guest lined up for next week. We're talking with Jonathan Thomas about OpenShot, which is, of course, video editing and video software. And then we have a few weeks with nobody scheduled yet. So if you have a project or you know somebody that does, let us know so that we can get them on the schedule. You can hit up the Hackaday tips line, or you can email floss@hackaday.com, and that will come to me as well. We appreciate everybody that's here, those that watch and those that listen, whether you get us live or on the download, and we should be back next week for another Floss Weekly. Very good.
Great. Well, thank you.
Yes, sir. Appreciate it. We had a couple of show title suggestions. One was Sometimes the Solution is Bigger Servers. The other one was Somebody Has to Write the Code. I think both of those are pretty good. I like them both.
Thank you. And by the way, I'm going to suggest if you have, since you have vacancies in, the next few weeks.
Yes, sir.
I'm going to see if I can find someone to talk about the Vista electronic health record system.
Sure. Yeah, absolutely.
So that's the one that is actually at the nation scale EHR system in Jordan, which is actually developed by the U.S. Department of Veterans Affairs.
Absolutely. Yeah, I'd love to talk to somebody about that. That would be great.
Okay, sounds good.
Yeah, let me know.
Well, thanks, Jonathan.
All right, thanks so much. Have a good one.
Okay, bye-bye.
Bye. All right. Cool. I like getting more guests. Let's see here. I like both of those show titles is the thing. I'm not sure which one I want to go with. Sometimes the solution is bigger servers. I like that. I think we're going to go with that one. All right. Hey folks, this week I talked with KS Bhaskar about YottaDB. It's the high performance database that's not SQL. Hey folks, this week I talk with KS Bhaskar about YottaDB. It's the high-performance database that's not SQL. Well, at least not yet. It's sort of coming. It's been around for a really long time, and it's tied closely to something called the MUMPS language. It is a deep dive into the technology behind YottaDB and its history. You don't want to miss it, so stay tuned. This is Floss Weekly, episode 858, recorded Tuesday, December the 9th. YottaDB. Sometimes the solution is bigger servers. All right, I like it.